Welcome back to your own channel Bal Vigyan Bharati with the mentor Avila Sarkar. In time, speed and distance, we have reached till problem number 28. 28 took a little bit much time to explain. So that is the individual problem that I have solved in one episode. Now we'll move on to the problem number 29. So 29 says three cars leave A for B, leave A for B in equal time interval in equal time intervals. Okay. They reach B simultaneously. They reach B simultaneously and then leave for C and then leave for C, leave for point C. This is another point C, which is 240 kilometer away from B, which is 240 kilometer away from B. The first car arrives at C an hour after the second car. The first car arrived at C an hour after the second car. The third car having reached C, the third car having reached C, the third car having reached C immediately turns back and heads towards B. Back and heads towards B. The first and the third car, the first and the third car meet a point that is 80 kilometer away from C. What is the difference? Is the difference between the speed of first and third car? Fine. Three cars leave A. There are 3 points A, B, C. From A point, three cars are leaving, but condition is that they leave at equal interval. Means if he takes T time to reach A to B, he left lesser time than means later that first this is first, this is second, this is third. First car has left earliest, then second car, and then the third car. So I am assuming first car has and as because they are reaching at B and simultaneously, the time taken to reach A to B is capital T, and after that small t lag, the second has started. So T minus T will that second car will take, and as because it's an equal interval, I'm taking double of the small t. The third car has started, so it will take capital T minus 2t time to reach this. This is the first condition. Then after immediately they have started from B, reach means they towards C. So what is happening while moving towards C? You can understand the third car having the highest speed, so he will reach the earliest because after even starting the last, he has reached B, so he is faster. So for this case, when they are starting from B simultaneously, he will reach C first. So condition is that while he has reached C, he is coming back again and met somewhere which is 80 kilometer from C with first car. So first car might have reached D on the forward journey, and he will catch up by on his return journey somewhere. Let's say this is D. So this is the scenario. And another thing is given that then leave for point C, which is 240 kilometer away from B. So this total distance is again said B to C is 240 kilometer. The point is, and the first car arrived at C an hour after the second car. So if first car even has to reach C, he will reach the first car arrived at C an hour after the second car. So the time taken for first car for second car, let's say this is capital T1 for B to C for second car. Okay, now that first car will reach T1 minus 1 hour, T1 plus 1 hour, because he is taking an hour more than second car. This is the condition, and the third condition they are meeting at each other. So let's say this is S1, this is S2, this is S3. So from there, as because the distance is same, so S1 into capital T here is equal to S2 into capital T minus T here is equal to S3 into capital T minus 2T. This will be the equation, because that denotes all the same distance. Speed into the time, the distance, speed into the time, distance, speed into the time, distance for all three. And here, as because they are reaching, so if it is 240, so for what amount one first car will move when he is when this is meeting with third car is 240 minus 80 will be the distance first car will move with the speed T1 S1 and the time T1 write it somewhere, S1 into I have assumed T1 plus 1, and the second car will move 240 not so. So I have assumed second car is moving in T1 time, so first car will take T1. So for them 240 kilometer will move S2 into T1 time, and that for the second car, first car, it will move S1 into T1 plus 1 hour. 1 hour more it will take. So from there, S2 into T1 is equal to this much. So we can build the relation there. So if I equalize this, and another thing is that when they meet first and third car, for them the equation would be 240 minus 80. It will be for first car what he is moving is equal to, the time is same, so the 240 kilometer with the speed S1 240 minus 80 by S1 will be the time taken for him to move this much, and in that time the third car will move 240 plus 80 by S2. So this will be the case. So S1 S2, if I take from this S2 by S1, sorry, S3, this will be the third car, sorry, will be third car. S3 is equal to 240 plus 80 is equal to 320. 320 will be the numerator, and 240 minus 80 is equal to 160, isn't it? So this will be the 2. So from there we can say that S3 is twice of S1. Now I need the difference. Now this equation is established, so I'll rub it out, and from there, from this 2, if I divide it, I will get 1 is equal to S2 T1 by S1 T1 plus 1. So this will give T1 plus 1 by T1 is equal to S2 by S1. Okay, so this will give, now from these two I will get 1 plus 1 by T1 is equal to S2 by S1. So 1 by T1, that means the time, is equal to S2 minus S1 by S1. So T1 is equal to S1 by S2 minus S1. So that I will get from this. The T1 can be represented in this form, whereas this, if I equalize from this, if I equalize this and this, these are two unknown, this and T can represent it. This is S3 is equal to this one, S3 is equal to S1. If I equalize this to S1, so from this 2, this and this, S1 is equal to S3 is equal to S1. So S1 into T, that is equal to 2S1 into T minus 2T. So S1 will be cancelled out. So from there I can say T is equal to 2T minus 4 small t. So T is equal to 4T small. So from there, if I equalize this, the first equation if I replace T is equal to 4T. So if I put here T is equal to 4T, so S1 into 4T is equal to S2 into 4T minus it into 3T. So TT will be cancelled out. So 4S1 is equal to 3S2. Okay, so I can put it here. So T1 is equal to S1 is equal to this one. So S1, if I put this one S1, okay, S2 I will put 3 by 4 of 4 by 3 of S1 minus S1. So this will give 1/3 of S1. S1 cancelled out, is equal to 3. T I am getting 3, and as because these are in kilometer and hour, so this will be 3 hour. T1 is equal to 3 hour here. So now it will be easy to calculate. Now T1 I've got this is 80. T1 I've got 3. So if it is 3, so so that speed will be how much, 240 kilometer is going in time T1 for say S2. So I need not to calculate S2, rather S1 is equal to T1 plus 1. So T1 is equal to 3. So S1 will be how much, 240 divided by T1 is equal to 3 plus 1 4. So that is equal to 60. So S1 is equal to 60. So then S3 is equal to 2 into 60 is equal to 120. Okay, into 2 into S1. So the difference is S3 minus S1, that is equal to 120 minus 60, that is equal to 60. So that is the 60 kilometer per hour will be the result. First and third car I am getting 60 kilometer per hour. So we will be very cautious while calculating. There are so many parameters given. So many equations you have to establish, and then after you have to solve it. So you check your calculation. I am getting 60 kilometer per hour. You might have understood how I have calculated with all these conditions. So this will be the answer for this. Okay, so moving to problem number 30. Problem number 30 is three friends A, B and C decide to run around a circular track okay. They start at the same time and run in the same direction A is the quickest, and when A finishes a lap, A is the quickest, and when A finishes a lap, it is seen that C is as much as behind B as B is behind A. When A completes 3 laps, C is the exact same position on the track as B was when A finishes 1 lap. Find the ratio of the speeds of A, B and C. So, three friends A, B, C decide to run around a circular track. Let be this be the circular track. Okay, they start at the same time. They are starting at same time. A, B and C starting at same time. and run in the same direction. They are moving in a clockwise, let's say direction. A is quicker when A finishes, so A is the quickest. A finishes a lap, it is seen that C is in the as much as behind than B. That means C is the slowest among all three. B is the mediocre one. So that we understood. So let speed of 3 be VA, SA, SB, SC I am taking. Okay. So the first thing I am assuming this one. So now condition is that when A finishes a lap and let the lap length is equal to perimeter P. Okay. So when A finishes a lap, so with the speed SA, that A is taking a time, let's say this is denoted by T, perimeter by speed time T. At that point and at that point, what is the condition? C is as much as behind. Let another thing, let when A completes a lap, B is D distant to A. So C is 2D D distant from B. So how much B is covering? Perimeter minus D with his speed in the time T. Time will be same, and that of your C will be T minus 2D by SC in time T, isn't it? This will be the equation, isn't it? Okay, fine. When A completes a 3 lap, C is exactly in the same position. So if I now if I denote thus SA in this case, so SA will be how much in terms of T? SA is equal to perimeter by time, SB is equal to P minus D by the time, and SC is equal to P minus 2D into time. Okay, capital T. The other way, okay, now fine. So all these assumptions, okay, fine. D distance, so I have taken distance, so I am rubbing it up. P is the perimeter and speed, that all are done. In the second part, when A completes 3 lap, C is in the exact same position. So A completing 3 lap and coming back to the starting point. At that time C is in the exact same position on the track as B was when A finishes 1 lap. So when A finishes first lap, B was how much? D distance apart. So now this is the position when A completes 3 lap. Okay. So for first lap, B was, this is B's position, this is A's position, this is C's position, this is again D apart. So now for the third lap, he had covered some distance. So there may be possibilities when C is taking second and third lap, A is taking second and third lap, C has reached only this much distance to get the position of B for the first lap, or else he by that time C can complete another lap and come back to this. So his position may be perimeter minus D, the first for the first lap B's position, or can be he has made another lap, okay, another lap and reached there. So this could be 2P minus D. This also can be possible. Completing 1 lap plus P minus D. So how will I get this? Completing 1 lap plus the second lap, he might reach B's position again. is it possible to get another lap and P minus D? Is not possible because C is already as 2D apart from in first lap. So that will increase definitely. So there cannot be possible that he will make 3p lap and a difference and can reach here. Means only the difference D is getting in third lap. That is not possible because in first lap already he is having 2D gap. So that gap will increase. So there is not possible when A is making 3p lap, he will be only D apart. It cannot be possible. So only thing is that this 2 is possible, where this can be represented in the form of 2p minus D. So this is the final position of B. But with this condition, for when A is making 3 lap, so speed and for 3 laps, speed of A into, let's say I am taking time T1 for SA, means to complete the third lap. So this T1, with this T1, B also move, C will also move, and they will get some position. So this, if I say, is equal to 3p. So what is your T1 then? 3p by SA. Now SA is what? 3p upon SA. I have already got p upon T. So this T will come here. So that is equal to 3t. T1 is equal to 3t. Now this T1 will be applicable for all these three. So for B, what would be the distance, actual distance towards SB into 3t. So SB is equal to what? P minus D by T into 3t. So TT will be cancelled out. So it will be 3 into P minus D. And for this you have understood. So for this is SB's distance, D1 and DB I can assume. So DC is how much? SC into the time will be same. This is the distance by SA also I have to write. Distance of A, that 3 lap, that is straightforward. Now SC is equal to how much? P minus 2D by T into 3T. So TT cancelled out. This will be 3 into P minus 2D. Now as per the calculation, this is coming 3 into 2B. But as per the condition of the sum, it has said that C will arrive at somewhere where B has reached for first lap, when A has completed first lap. So this is the position, means this position can be achieved in any lap. So either C will reach this position. Now I may equalize 3 into P into 2D for first case. If I equalize this will be the one condition when he will get the position of B when A completes the first lap. So 3 into P minus 6 into D, that is equal to P minus D. So this is equal to 2P is equal to 5D. Okay, so okay, fine. So P is equal to 5D. So from here I can assume P is equal to 5 by 2 D. Now this is the one relation will be useful to get the ratio of 3. So SA is to SB is to SC. That ratio I have to find. So this is P by T is to P minus D by T is to P minus 2D by T. For first case, when I am equalizing with this. Okay. Now T will be cancelled out. P is equal to 5 by 2D is to P minus 2D, P minus D. So if I deduct D from here, so this will be 3 by 2. 3 by 2D is to, if I take P is equal to 5 by 2 and minus 2, this will be 1 by 2D. So D will be cancelled out. 5 is to 3 is to 1. This is the one solution. If I equalize this, there would be another possibilities to have this uh, uh, true is equal to 3 into p minus d, that is the actual distance traversed with respect to the velocity, and as per the condition this could be this also b's position. B also can get this position when A completes total lap, this position, so that could be in second lap also. So 3p minus 6d, that is equal to 2p minus d. So this is equal to p is equal to 5d. Now put it there again. This is equal to p is to t is cancelled out, already I have shown, so I will not repeat that step. So this will be the case. So this p is equal to 5d is to p is equal to p minus d is equal to 4d, and is to 5 minus is equal to 3d. So d will be cancelled. Another ratio will be 5 is to 4 is to 3. So earlier was 5 is to 3 is to 1, and this one is equal to, so there could be two ratios possible to fulfill this condition of the sum. So there I will end my class today. I will move on to the problem number 31 and onwards in the next episode. So thank you for now. Bye.